density, square velocity. In a canal, the flow velocity is very low, about 1 meter per second, compared to the wind velocity, which is 30 meters per second or more. But the water density is 800 times the density of air. 30 times square is about 900, which is of the same order of 800. So they cancel out. So the two mechanisms are equivalent. So this simple comparison shows that a geomembrane in a canal, provided there is a hole in the geomembrane, is as likely to be uplifted by water than an exposed geomembrane is uplifted by wind. So this phenomenon should be taken seriously, because we know that geomembranes are frequently uplifted by wind if they are not properly ballasted or anchored. So therefore, in a canal, we should also provide ballasting and anchorage of the geomembrane. At the Tekapo Canal, the ballast was done using locally available cobbles, but a portion of geomembrane was left exposed to water flow to ensure high flow velocity. So this is the cross-section that was adopted. And here we see a few slides showing the construction of this lining of the canal. Here is the placement of the composite geomembrane that was selected. Here, the placement of the ballast at the bottom of the canal and the placement of ballast on the side slope. I had no time to describe the long design process, but stability calculation had shown that we needed to reinforce the ballast on the side slope. So a geogrid, another type of geosynthetic, was used to reinforce the ballast, as you see here. And over there, we see a portion of geomembrane left exposed. As mentioned in the preceding slide, the alternative to ballasting is anchoring. So here, a photo from another canal shows anchoring. Here, the substrate is concrete. It was an existing concrete canal that was relined with a geomembrane. We have anchorage with stainless steel strip at the top, again stainless steel strip at mid-height, and at the bottom ballasting with a layer of concrete. Now, the preceding case history showed the rehabilitation of existing canals using geomembranes and also other geosynthetics like geotextile and geogrids. The next case history presents a new canal lined with a geomembrane. This is the Toshka Canal project in Egypt. It was and still is the largest geosynthetic project in the world, with 20 million square meters of geomembrane installed. The canal is very large, 30 meters wide at the base, 7.5 meters deep. The safety was considered very important, and in fact more important than the economy on this project, which is not typical of irrigation projects, which are often low budget projects. So this approach, safety approach, led to the selection of a thick geomembrane protected by a thick concrete placed on slopes that are not as steep as usual, 2 horizontal to 1 vertical, less than the usual practice in Mars. The cross-section from top to bottom was very safe, 200 millimeter fiber reinforced concrete and 100 millimeter